Hi, today we are going to learn how to interpret distance time graph and how to find the speed and average speed from the distance time graph. For the first diagram above shows a motion of a car. OA is part. The car moved from town P to town Q in 1 hour. AB, this part. The car stopped at town Q for 3/4 hours or 45 minutes. The line BC, the car continued the journey from town Q to town R. Okay, so we look at diagram 2 here. Diagram above shows a motion of a taxi. The taxi moved from town A to town B in 30 minutes. Line PQ. The taxi stopped at town B for 25 minutes. 55 minus 30 equal to 25. So 25 minutes. Line QR. The taxi moved back to town A in last 35 minutes. So when graph go down means the vehicle move back. Okay. Example 4. The distance time graph shows the motion of a car and a tour bus. Graph OA represents the motion of the car from Puchong to Malacca. Graph BC represents the motion of the tour bus from Malacca to Puchong. Determine the difference in speed in km per hour of the two vehicles. As we know, the formula for speed equal to difference in distance traveled over corresponding difference in time. Corresponding difference in time is 2 minus 0. So, speed of the car equal to 75 km per hour. You also can write it as 75 km per hour like this. Now we find the speed of tour bus. Speed equal to 0 minus 150 divided by 3 minus 0 equal to negative 50 km per hour. Why the answer got negative sign? The negative sign means the tour bus and the car move in opposite direction. But we cannot write the answer for the speed in negative. So you change to positive. So speed of tour bus equal to 50 km per hour. Okay. So now we want to find the difference in speed in km per hour of the two vehicles. Hence, difference in speed equal to 75 km per hour minus 50 km per hour equal to 25 km per hour. Example 5. The distance time graph shows the motion of a car for a period of 4.5 hours. A. Determine the duration when the car is stationary. So in this part, the car is stationary. So what is the duration? Here, 3 minus 2. So stationary period equal to period of the car stops. 3 minus 2 equal to 1 hour. A2. The speed in km per hour of the car in the first hour. So car in the first hour is here. As we know, the formula for speed is distance over time. but distance traveled in the first hour is not known. So how? Speed of car in first hour and first 2 hours are the same because at the same straight line, gradient are the same. Okay, so speed of car in first hour equal to speed of car in first 2 hour. So the speed is equal to 150 minus 0 over 2 minus 0 equals to 75 km per hour. B. Describe the motion of the car for the last 90 minutes. So where is the last 90 minutes? Last 90 minutes actually is 1.5 hour, right? So it's this part. So speed of car is 270 minus 150 divided by 4.5 minus 3 equals to 80 km per hour. So when we need to describe the motion of the car, we need to have the distance, speed, and the time. So the car travels for 120 km with a speed of 80 km per hour in the last 90 minutes. Next example, determine the total distance in kilometer for whole journey. Okay, so now we look at the graph. From town A to town B, 70 km. Here stationary means car stop here. Okay, after that, town B go back to town A. Total distance equals to 70 plus 70 equals 140 km. A2. The value of t if the taxi drive with speed of 100 km per hour from town A to town B. Or from town A to town B, this part, or P here. So 100 equal to 70 minus 0, the distance, over the time. Don't forget here is minutes, but the unit is in hour. So 20 minus 0 must divided by 60 because we changed the unit to hour. So 100 times t over 60 equal to 70. T over 60 equal to 70 over 100. T equal to 70 over 100 times 60. T equals to 42 minutes. B. Describe the motion of the car from town B to town A. Before we describe the motion, we need to find the speed from town B to town A. So how to find the speed? 70 minus 0 divided by 90 minus 55. Don't forget, divided by 60 because change the unit from minutes to hour. Equals negative 120 km per hour. So as we know, we cannot write speed in negative. So automatic change to positive, right? 120 km per hour. So how to describe? The taxi travels for 70 km with a speed of 120 km per hour in last 35 minutes. Motion with different speeds. The speed of a motion usually changes in a journey. In such situation, average speed is used. So average speed equal to total distance over total time. Example 7. Zabita wants to visit her friend in Muar. The distance time graph shows her journey by car from Segamat to Muar, passing through Tangkat. A. Calculate the average speed in km per hour of Zabita's journey from Segamat to Muar. Okay, so as we know, the formula for average speed equal to total distance over total times. So total distance from Skarmat to Muar is 80 km divided by total time 1.5 hour. Average speed equal to 55 1/3 km per hour. B. If the rate of change in distance of the car from Skarmat to Tangkak is 50 km per hour, calculate the distance in kilometer between Tangkak and Muar. What is rate of change in distance? That is B. Now we want to find the distance Tangkak from Skarmat. Distance is equals to 50 km per hour times 1 hour equals 50 km. So here S equal to 50. The question asks the distance between Tangkak and Muar. So Muar is here, Tangkak is here. So that's why we need to minus. So distance between Tangkak and Muar equal to 80 minus 50 km equals 30 km. C. Describe the motion of the car from Skarmat to Muar. How to describe? The car moved for a distance of 80 km in 1.5 hours with average speed 55 1/3 km per hour. So now why I use average speed? Because here we have different speed. So we need to mention average speed here.
If you like my video, please feel free to like and subscribe to my YouTube channel. Thank you.